Hello, Mr. Luong. This is my FRQ number 8. So for part A, I know that the VI is going to be the final velocity after the kick. So let me define that. And I know the ball is being kicked for 0.05 second. So then to find here, let me just establish some values first. So the VFX and VFY. VFX is going to be 20 cosine of 37. And VFY is going to be 20 sine of 37. So then it's just going to be 15.97 meters per second. And this is going to be around 12.04 meters per second. And I know that the acceleration in the x is going to be VFX minus VIX over t. And then AY, or the acceleration in y, is going to be VFY minus VIY over t. And both of the VI's for the x and y are 0 because the ball started at rest. And then the t is going to be the same because the ball is being kicked by the same person, but with the same, I guess, force for the same time. Just different acceleration in the x and y. So then I'm going to solve for the acceleration in the x and acceleration in the y. But plug in what I know. So VFX is going to be 15.97. Time is going to be 0.05. AY is going to be 12.04 over 0.05. So then AX is 319.45. And AY is 240.73. Now a total is going to be rad ax squared plus ay squared. And I got this from Pythagorean theorem. So then a total is going to be 319.45 squared plus 240.73 squared. This a total is going to be 400 meters per second square. Now this, I can use this A total to find the average net force acting on the ball during the kick. Because net force is mass times A total. And net force is going to be the mass of the ball is 0.5. And then A total is 400. So the magnitude of the average net force exerted on the ball during the kick is going to be 200 Newton. And for part B, I know I can use D equals to VIX over T. And just plug in what I know. So 32 equals to, what was VIX again? 15.97. And then T equals to 32 over 15.97, which should get you T equals to 2 seconds. In part C, I know I can do VFY equals to GT plus VIY. So doing this will help me find the final velocity when it hits the fence. The final velocity in the y when it hits the fence. So VFY equals to negative 9.8 times 2 plus 12.04. So then VFY is going to be negative 7.56. Now this is not the instantaneous velocity because it's only the velocity in the y when it hits the fence. You need also, so to find the instantaneous velocity, it's going to be like a total before because Pythagorean theorem. So to find the final velocity, you gotta do VFX squared plus VFY squared. So I know VF is going to be 15.97 square plus negative 7.56 square. So VF is going to be 17.67. But velocity needs direction as well. So to find direction, I gotta do 10 of inverse of 10 of the VFY over VFX. So VFY is, I'm just gonna use a positive, or because I'm gonna, say below the positive x-axis anyway, so just use a positive. Or do you want me to use negative? I think I should use negative. Now I think about negative 7.56 over 15.97. So the data is going to be 25.34 degrees. Now my full answer, this is my full answer. VF, the instantaneous velocity of the ball after it's traveled 32 meters down, which takes 2 seconds, is going to be 17.67 meters per second. And then the angle is going to be 25.34 degrees below the positive x-axis. That is my full answer. And then for part D, I know delta y is going to be 20 sine, it's going to be what, VIYT minus 4.9 t squared. So then VIY is going to be 12.04 t minus 4.9 t squared. And I use this displacement formula because I want to find the time when the ball travels to distance up, so that I can use that to find the velocity. So then the displacement in the y is going to be 2 equals to 12.04 t minus 4.9 t squared. And then I just use my, quadratic formula in the calculator to find t. Okay, so t, there were two answers, 0.18 second and 2.28 second. And I know this answer does not make sense because that is the answer when it travels like going down. And it's also greater than the time it takes to hit the fence, because the time it takes to hit the fence is 2 seconds and this is 2.28. So it's like, yeah, it's way past the fence. So then you are going to use this time right here, 0.18 second. So I'm going to do the same thing I did in part C to find the final velocity. Plug in 0.18 plus 12.04. VFY is going to be 10.28. And now I do the same thing again with the VF by doing the Pythagorean theorem, like square rooting VFX squared plus VFY squared. So this is going to be squaring the VFY squared plus VFX squared. So it's going to be 10.28 squared plus VFX squared, which is going to be 15.97 squared. So then VF, or the instantaneous speed at the moment when it hits 2 meters from launch, which takes 0.18 second. Wrong one. Yeah, when it has risen a distance of 2 meters, not travels down 2 meters. Yeah, my bad. But when it has risen 2 meters, which takes 0.18 seconds, the VF is going to be 19 meters per second. So the instantaneous speed after the ball has risen a distance of 2 meters is going to be 19 meters per second. Okay, so for part E, I have to sketch the horizontal and vertical components of the velocity of the ball as functions of time until the ball reaches the plane of the fence. Okay, so for horizontal component of velocity, I know it's going to stay the same because after the kick, there's no force acting on it. in the x, so the acceleration, there's no acceleration, but there is a force acting on the y. That's why the that's why the Vy changes, but the Vx stays the same because there's no other force acting on it, but Vy has the force of gravity acting on it, which is why Vy changes, but Vx stays the same. So now I'm going to draw Vx. So Vx was like 15.97, which is like close to 16, and this is like 16 right here, right? So I guess I should draw it like a bit below that. Let's draw right here. Oh no, that's not a bit below. Okay, it's very close to 16. Yes, and then I draw it until 2 seconds. 2 seconds. Okay, that is a good enough straight line. So that I stop at 2 seconds because that's when it reaches the plane of the fence. And now I'm going to proceed to the velocity in the y. So the velocity in the y is started at 12.04. So this is 10, 11, 12, so around there. And then let's erase that part. Oh my god, I erased that too. Okay, 11, 12, 12 right there. 12.05, somewhere around there. And then the VF at 2 seconds, VFY at 2 seconds was like negative 7.56. So it's going to be like 6, 7, so like somewhere around, let's say, like here, right there. Okay, so now I'm just gonna like try my best to connect the dots. Okay, very nice. So this is going to be the sketch for the velocity in the x direction, and this is going to be the sketch for the velocity in the y direction. Yes. So then for part E, so what angle theta should a soccer be kicked so that it strikes the bottom fence? And for the soccer to hit the bottom fence, this means delta y is going to equals to yes, so oh no, what just happened? Okay, sorry. So for this one, I need to find the angle when it yes, sorry, what is wrong? Okay, so for part F, I know I can use the range formula, which is d equals to vi squared sine 2 theta over g. And now I know I can plug in the d, which is 32 times g, move g by multiplying to both sides, and then vi squared is going to be 20 squared equal to sine 2 theta. So now sine of that is 0.784, which equals to 2 theta. But you want like 2 theta is going to be 51.63, but you only want theta, so you divide both sides by 2. So then theta should be 25.81 degrees. Okay, done.